Hi everyone, and welcome to the last part of our tutorial session about how to use OpenBow-Shok2D program. So let's return to our code. I prescribed our circular cylinder coordinates of not coordinates, but the number of grid points and the grid type, and I have only one window where I can put my Mach number, density, and temperature. I can put any numbers theoretically, and let me put stop in here. So the only thing I need to do is just to push compute and go ahead and solve it. Now there are two tricks about this code. First one is that it may take a while, so don't worry too much. What MATLAB is going to do, it's going to generate C file using code generation technique. So depending on the machine, it may take some time, and then it's going to proceed and solve the problem. Depending on, again, the power of your machine, it may take 5 minutes or it may take 30 minutes. Also, it depends on your geometry, your amount of grid points, and many things. But you will get solution, except one little detail. This code probably has a certain bug somewhere, still does have, even though I have been trying to find it for months, and I still couldn't manage to find it. So it's going to work perfectly for subsonic regimes, no doubt. For supersonic regimes, though, and hypersonic regimes, it's gonna work nice depending on geometry. The more blunt the geometry is, the less Mach number it can calculate, which is weird. I mean, that's the main idea about hypersonic speeds. You generate more blunt bodies to avoid heat transfer. So, but unfortunately, this code so far can do only this thing. But I'll definitely try to find this bug and kill it as fast as I can. I know for the circular cylinder the maximum Mach number you can make is 8. I know for more slender bodies like the logo body, the maximum Mach number was I think 10. And if it's a little bit more slender, but if it still has kind of circular shape, it can go until Mach number 20 or 15. I think I tested one geometry at Mach number 20 and it worked perfectly fine. So it takes time to understand what geometries you can use and you cannot at the moment. I'm sorry that I cannot give you guys the better solver so far, but I'll definitely work on it, and maybe you guys will have suggestions how to solve this problem, and maybe you know how to solve it, and that will be a really cool thing. So the only thing you push compute button, and then you just create global local time step, where global time step is that time steps equal at each grid point, which is perfect for time marching solution, which is the next update goal, to have a time marching solution so you can see how it works. And local time step has local delta t, time difference at each point, so it improves the solution. So if I click it, it begins to run. I'm not going to do it right now because it's going to take a while. But what I can do and show you solutions. But probably let's kill it. So I ran a sample solution of this problem and I got some sample results. So we can see temperature distribution, which looks okay, except maybe some points. Probably clustering wasn't that great, but it highly depends on grid. But overall, the geometry looks fine and the temperatures look okay. They are multiplied by 10 to the fourth, so we can also see velocity and Mach number. This ugly picture is a velocity contour plot, actually. So you can see velocity vectors here and how the flow goes. So you can trace the behavior of the flow. And Mach number is just a Mach number distribution from your free stream Mach number to until almost zero at the stagnation point. And the final one is the pressure distribution. So I have my pressure and I have my CP curve. For more complex geometries, you may have some kind of a part of CP going this way and part of CP going, in a weird way, because geometry is not symmetric. But it's okay. So that's the only thing I have for you right now. So feel free to comment, feel free to ask questions, give your suggestions. I will get any feedback and try to improve the code as much as possible. So good luck and have good coding.